Hey guys, today we are going to be talking about polynomials, like what they are and how to solve these different kinds of problems whenever we see these in algebra or on the GED test. So a polynomial, that probably, maybe you've never seen the word before, maybe you've heard it, but you still have no idea what it is. But basically, polynomial kind of breaks down into two different words. So poly just means more than one. So poly means, hey, there's more than one part. And nomial means algebraic terms. So basically, these kind of problems just mean, hey, there's more than one algebraic term. And all an algebraic term is, it's just a fancy word for a piece of an algebra problem. So basically, if they're separated by pluses and minus, that type of thing, that is a separate term. And we can tell that they're terms by the letters stuck to them, or if there aren't any letters. So for instance, this has an x squared stuck to it. There aren't any other ones with an x squared stuck to it, so that is one term. This one in the middle, we have 10x. So it has an x stuck to it. There aren't any other ones with a plain old x, so that one's a term. And then we have the plain number 8. So this polynomial has three terms, or basically three pieces of it, three different pieces. And so whenever we are dealing with polynomials, it's just like any other math problem. We can add them, we can subtract them, we can multiply them, we can divide them. And that is what I'm going to be showing you how to do in this particular video. So now adding a polynomial, it looks scary, but I promise it isn't. If you know how to add, then you're good. You can do this. So what we do whenever we get a problem like this is we look for what are called like terms. Numbers that have the same exact letter stuck to them that can go together. So for instance, I'm going to look over here on the left side, and I have a 4x squared. So it has an x squared stuck to it. So I want to look on the other side of the problem and see if there is also an x squared. There is. I have a 3x squared, so there's a 3 stuck to it. So basically what I do, I'm adding, so I just add these together like normal, and they just keep that x squared that's stuck to it. So 4 plus 3 gives me 7, and the x squared is just going to go with it. Then I'm going to do the exact same thing for this 5x and this minus 8x. So again, they have the same letter. I can go ahead and add these together. So what's 5 plus negative 8? We get negative 3, and that letter x goes with them. And then lastly, we have a 7, that's just a regular number, and we have a 12. And so we're adding these together, so what is 12 plus 7? 19. So that is what we get whenever we add these polynomials together. We get 7x squared minus 3x plus 19. So all we're doing is adding the things together that have the same exact letter. So subtracting is the exact same thing. It's just we're subtracting them from each other instead of adding them. So just like whenever we added, we need to make sure that we subtract the stuff that goes together. So over here, I have a 3x to the third. Now on this other side of the problem, do I have anything that has an x to the third? So in this case, I don't have anything with an x to the third, or with an x and an exponent 3. So there's nothing I can subtract from that. So it's just going to come down and be by itself. So I'm done with that. Sometimes it helps if you mark them out as you go. Now after that x to the third, I have this minus 5x. So on that second half of the problem, do I have anything that has just the plain letter x stuck to it? Yeah, I have this 6. So what I'm doing, I'm going negative 5x minus 6x. So what's negative 5 minus 6? I get negative 11. And so that letter x just goes with it. So this is, oops, so I'm done with that one. I'm done with that one. Then over here on this side, I have an 8 and a minus negative 9. So if you are subtracting, so again, 8's a regular number, 9 is a regular number, those are going to go together. So whenever you subtract a negative number, it's the exact same thing as adding a positive. So really I'm going 8 plus 9, which is what? 17. So I have plus 17. So I added those, and I added that. So sometimes you're going to have stuff left over, or I subtracted them, sorry. Sometimes you're going to have stuff left over on one of the two sides. So I have this minus 7x squared, but on the first half of my problem, I didn't have any other x squareds. That's the only one that's in this problem. So I'm not going to subtract it with anything. It's just going to come down. So 7x squared, and then that minus sign is going to come with it. So whenever I work out this problem, I get 3x to the third minus 11x plus 17 minus 7x squared. And so that's what we get. That is our answer. But if you're taking the GED test and let's say it's a multiple choice question, this isn't going to be in the same order that it would be on one of the multiple choice selections. And the reason that is that they put the answer in the order of biggest exponent to smallest exponent. And so when we get our answer, we need to do that so that we can make sure that it matches up with the multiple choice options. So this 3x to the third, that x to the third is my biggest exponent. There isn't an exponent that's bigger than 3. So that one is going to be first. Now, what number comes after 3? 2. So do I have any terms here that have the exponent 2? Right, this minus 7x squared. So I'm going to put that one next. And then, so after the number 2 is the number 1. Now, they don't usually write exponents as the number 1. So usually it'll just be a letter with no exponent, but it means the exact same thing. So I have a term here that doesn't have an exponent next to the letter. I have minus 11x. So that's going to go here. And then I just bring down what I have left. That's a regular number. So I have a plus 17. So that's going to come on down. So my answer is 3x to the third minus 7x squared minus 11x plus 17. So it's basically the exact same thing when we add or when we subtract them. It's just, we're just doing a different operation, but it has the exact same rules for either one that you're doing. Now, multiplying is a little bit different. So, when there are numbers in front of it, we just multiply like normal. But the thing that is different with multiplying is that we can multiply everything together. They don't have to be like terms. They don't have to have the exact same letter for me to multiply them. And then if they do both have the letter or the variable. So for instance, I have a 4x times a 2x squared. So if they have the same variable, what you do is you add the exponents together. Because it's like you're saying, oh, I have 2 x's and I multiply it by 1x. It's basically saying, hey, I have 3 x's. So for instance, what we do on this part, it's like we go 4x and pretend that it has the exponent 1 because there is no. So if there's not an exponent listed, just pretend that there's a number 1 there. And we're going to multiply those together. So whenever we multiply terms that have the same variable, that have the same letter. So first we just multiply the big numbers that are out in front, just like normal. So 4 times 2, I'm going to multiply that like normal, and when I do that, I get 8. Now, because these two have the same letters, that x letter is going to come down. But what I do, since I'm multiplying variables, I'm going to add their exponents together. So really, I end up with 8x, and then it's 2 plus 1. And what is 2 plus 1? We get 3. So we get 8x to the third. Now, when we do the second part of this, 4x times y, they don't have any like terms. So this plus sign is going to come on down. And so imagine there's a number 1 in front of our 4. 4 times 1 gives me 4. And then I'm not multiplying an x times another x or a y times another y. So all we do is just stick those together. So I get 8x to the third plus 4xy. And so that's it. So if we are multiplying letters together and they're the same letter, we add the exponents. If there aren't any other letters like that, we just stick them together like we did with the 4xy. Now when we talk about dividing, we actually also end up talking about factoring. So we're going to go from this slide and then we'll go back to dividing. Factoring is a lot like dividing. You basically figure out what you multiplied together to get the problem that you have. So the way that we do that, it's like we set up two different sets of parentheses and we figure out what we multiplied to get these answers. So, like I said, when we factor, we're figuring out what we multiplied together to get these answers. And so what they basically do, they figure out what set of parentheses multiplied together gives us this problem right here. And so the way that we get this first term, this 3x squared, is that we multiply the first terms in the parentheses. So let's think of it like division. What do we have to multiply together to get 3? So the only things that we can multiply together to get 3 is just 3, and the number 1. Now, it has x squared. And so the only way that you can get x squared is by going x times x. So I know there's going to be an x stuck to the number 3, and there's going to be an x stuck to the number 1. So I know that that is how I get that first term there. So I multiply these first things together to get that 3x squared. Now, the order that we usually go in is first, outer, inner, last, but since we're factoring, we are actually going to be looking at our last number, this -8. So what we're going to do, we're going to figure out what we multiply together to get this -8. And to get that -8, we multiply our last two terms together. So if we have a -8, we can multiply 2 and 4 together, and we can multiply 1 and 8 together. And since our answer ends up being a negative, that means that one of our numbers has to be negative, and the other one has to be positive. But what we also think about is what numbers can we add together to get 10 as well? So, to get this number 10 that's here in the middle, we multiply the outer numbers and the inner numbers. So, basically, we multiply the two numbers that are on the outside, and we multiply the two numbers that are on the inside, and we add the answers together. So we have to think about how we end up getting the number 10, as well as how we're going to get the number -8. So let's look at these. So we have a 3 times a 1, which is going to give us 3. But then we also have to think about what numbers we're going to end up multiplying here. So to get 3 times, to get a number 10, we can either add the number 7 to it, or maybe it's going to be a negative number. So maybe this is going to be -3. Actually, disregard, that is not going to be a -3. So let's just try some different numbers with this. So to get an 8, let's say we have a 2 times a 4. And let's say that we have a positive 4 and a negative 2. So let's see if we end up getting the answers we're supposed to. So 3 times 1 gives me 3, and then x times x gives me x squared. So did I end up with the 3x squared that I do up there? Yes, I did, so that's good. But now I have to multiply my outer numbers. So my outer numbers are the numbers on the outside. So I have a 3x times a 4. So 3 times 4 gives me 12. And then that letter x is going to be stuck with it. Now I'm going to multiply my inner numbers. So my numbers on the inside are a negative 2 and a positive 1x. So negative 2 times 1 gives me negative 2, and then the x goes with it. Then I'm going to multiply my outside numbers. So I have a negative 2 and a positive 4. And when I get that, I get negative 8. So I end up with a 3x squared like I'm supposed to at the beginning. I end up with a negative 8 like I'm supposed to at the end. But look at these two numbers in the middle. I have a positive 12x and a negative 2x. So those have the same letters, so I'm going to combine them. So basically I'm adding positive 12 and negative 2, and when I do that, what do I get? I get positive 10x. And then I'm going to bring everything else down. So I got 3x squared plus 10x minus 8. That was what I originally had. So that means that these are my factors. 3x minus 2 times 1x plus 4. So now that we've talked about this, let's go back to our division problem. So we basically have to factor the top part of our problem before we can divide. So we have 3x squared minus 3x minus 10. So remember, I'm going to set up two different sets of parentheses, and then my x plus 2 is just going to stay the same. So I've got to ask myself, what in the world do I multiply together to get x squared? So the only way to get that is just to go x times x. And so to get this term, that is when I multiply the first numbers, or the first terms in the parentheses together. So these have to be x and x. But then I've also got to think about this negative 10. What can I multiply together to get a negative 10? Well, I can do 5 times negative 2. I can do negative 5 times positive 2. I can do negative 10 times positive 1. Or I can do positive 10 times negative 1. And so what we have to do is we have to see which of these sets of numbers, when I add them together, gives me negative 3. So when I add 5 and negative 2 together, I get positive 3. So it's not that one. When I have negative 5 and 2, when I add them together, I get negative 3. And then negative 10 plus positive 1 gives me negative 9. And 10 minus 1 gives me positive 9. So that means it's got to be negative 5 plus 2. And so here's the thing with division with these kinds of problems. See how I have an x plus 2 on the top and I have an x plus 2 on the bottom? We're dividing. Whenever you have the same number on top and bottom when you divide, they just cancel each other out. So our answer is x minus 5. And so that is how we divide. And I know that's a little bit more complicated, but let's practice some of these together and we'll go through all of them. So here's an example of subtracting polynomials. So remember, we want to look for things that have the same letters. So right here, I have an x to the third. Now, are there any x to the thirds on this side that I can subtract from it? No. So that one is just going to be by itself. So I'm done with that one. And then here I have 5. Now, are there any regular numbers on this side that can go with it? Nope. So I'm just going to bring down the plus 5. But then here I have a 2x squared. Are there any factors or terms on the other side that have an x squared? Yeah, I have this minus x squared. But notice how it's minus a negative x squared? That's the same thing as adding. So pretend there's a number 1 in front of this. What's 2 plus 1? 3. And then that x squared is just going to go with it. So I'm done with this one. Now, I have this 3x. Now, are there any other just plain x's? Nope. So that minus sign is going to go with it. I'm just going to put minus 3x. Then I have a 2x to the 4th. Does it have any x to the 4ths that go with it? No, that's the only one. And just like with that x squared, we have a negative and then a minus. So imagine you're multiplying a negative 1 times a negative, and we get plus 2x to the 4th. And now our last step is just to put this in order from the biggest exponent to the smallest exponent. So our biggest exponent is this 2x to the 4th. And then we have x to the 3rd. Then we have x to the 2nd. Then just a plain x. And then our regular number always goes at the end. Okay, let's say that we had this problem. So we have a 4x outside the parentheses with a 2x squared plus y in the parentheses. Now, anytime you've got a number outside parentheses, you are multiplying. So it's like we're going to distribute that 4x to everything inside the parentheses. So first, it's really like I'm taking 4x times 2x squared. So what I'm going to do, I'm going to multiply my numbers just like normal. So 4 times 2 gives me 8. Now I'm multiplying my x and my x squared. So whenever we multiply variables that have exponents, we add our exponents. So imagine there's a 1 there, and 1 plus 2 gives me 3. So we get x to the 3rd. And then I'm going to do the same thing with my second term. So I have 4x times y. There's no numbers that I can put together. So that 4, imagine there's a number 1 there. So that 4 is just going to come on down. There's no other x's to multiply the x by. It's going to come down, and the same thing for y. So we get 8x to the 3rd plus 4xy. And then this one, we get 5z y squared times zy to the 4th. So I don't have any other regular numbers, so 5 is just going to come down. Z times z, imagine there's 1's, so our exponent is 2. And then our y's, we have a 2 and a 4, so we're going to add our exponents together because we're multiplying, and we get 6. Now on this one, we are adding and subtracting. So I have a 4 n to the 4th. Are there any other n to the 4ths here? Yeah, this one. So what is 4 minus 3? 1. So I'm just going to put n to the 4th. Now I have a regular n right here. Are there any other plain just letter n's? No, so that one's just going to be by itself. And then I have a plus 4 and a minus 1. So those are regular numbers. Those are like terms, they can go together. So what's 4 minus 1? 3. So we get plus 3. Now this one we are dividing. So just like with our other problems, we have 42 divided by 6. So we're just going to divide those like normal. So what is 42 divided by 6? 7. And now our letters that are the same, we can divide those by each other. And when we divide, we subtract exponents. So really it's like g to the 11 minus 4. So what is 11 minus 4? 7. And same thing with the letter h. So it's h, 15 minus 10. What's 15 minus 10? 5. So we get 7g to the 7th and h to the 5th. Now this is an example of where we need to factor. And so remember, with factoring, we think about first, outer, inner, last. So we set up two sets of parentheses and we figure out what goes where. So this first is what gives us the x squared. So the two terms that are first in the parentheses, when they get multiplied together, they're going to give us x squared. So when we go x times x, we get x squared. So that tells me I'm going to put x's there. Now we're going to look at our last term, which is this negative 10. So to get negative 10, we are multiplying this number, whatever it is, times this number. And so let's think about the number 10. We can multiply 2 times 5, or we can multiply 10 times 1. And what we have to think about is which of these, when they're added together, so whether one's negative or positive, which of those added together is going to give us a negative 3. So 10 plus 1 will give us 11. 10 minus 1 will give us 9, so it's not that. What about 2 and 5? Yeah, so if we had 5 minus 2, we would get 3. So basically, one of these numbers is going to be positive and one of these is going to be negative. So I'm going to go ahead and fill those in here. So if I have a negative 5 plus 2, or if I have a negative 2 plus 5, which of these is going to give me a negative 3 is my answer? This one. So that means the minus sign is going to have to go in front of the 5, and the plus is going to have to go in front of the 2. So we get x minus 5 and x plus 2. And then lastly, let's do this one. So sometimes they're going to put a number on the other side of the equals instead of making it equal to 0. But all you do when that happens is just subtract that number on both sides, or add if it's a negative, to move it over. So now we get 2x squared plus 5x minus 12 equals 0. And now we can just do what we have been doing. So I have a 2x, and so the only way I can get 2 is by multiplying 2 and 1. So I know that's going to end up at the bottom in my front, as my front terms. But then I have a 5 in the middle, and I have a 12 here. So this number's positive, so that means my bigger number is going to be positive. And then my back number is negative. So to get a negative, I have to multiply a negative and a positive. So think about what we can multiply together that gives us 12. We can have 3 and 4. We can have 6 and 2. Or we can have 12 and 1. But see how we've got this 2 here? So basically, to get the number in the middle, the number that goes here is going to be multiplied by the 2, and then we're going to add it to this other number right here. And so we have to think about that whenever we figure out what numbers are going to go there. So let's say that I had a 6 and a 2. Say I put a 6 here and a 2 here. So let's say this one's my positive. So 6 times 2 gives me 12, but if I add positive 12 and negative 2, I'm not going to get 5. So that doesn't work out. But let's try this one. So 2 times 4 is going to give me 8, and then 3 times 1 is going to give me 3. So I'd get a positive 7 plus a negative 3 would give me, a positive 8 minus plus a negative 3 would give me a positive 5. So I hope this helped. I know we covered a lot in this video, but check out the self-check in the Google Classroom, and we'll try to cover some more of this material as well. I know it can be a little bit tricky, but I hope you guys have a great day, and we'll talk to you soon.